Hi, good morning. Um, you are going to study now a new concept which already you are studied in your physics. But related to the mathematics, we need to study about something that also. Okay, so let us start with something that. Yes, so look at on the board. I drawn three pictures at here. One is cube, another one is pillar, another is a car, moving car it is. Okay, so now think, if supposedly I ask you a question. So what is the question here? If I say that, what is the volume of this cube? Obviously you can say that, what if supposedly its area, if its side is of A units, then you can say its volume will be what? It is A cube. Okay, if I say that it's area of any face, the area of face of this cube, so what you can say its area is A square. So means you are calculating here volume and here you are calculating area, isn't it? So now come at here. If I ask you what is the height of this pillar, supposedly you can tell me, sir, it is about 5 meter. Yes, so means you can able to measure this from the top to bottom, otherwise bottom to top here. Okay, so now here comment here. So there is a car. So if I applied a force in this direction, so what will happen? The car is start moving forwardly. Yes, if supposedly I applied a force in this direction, what happens? The car is moved in this direction, so backwardly. So means while measuring some quantities which are related with some material, so means the properties which are related with the materials, they can be calculated by measuring. Yes, so such properties are called the physical quantities. What we call the physical quantities. Physical quantities. In this physical quantity, we can divide in two types. Okay, so mainly in divide two types. So now you can observe here, there are some properties which are independent of its directions, and which are some properties they are depending on direction. For example, if I say that here, so look at here. If I say, so what I said here, what is the height of this pillar? So means what happens? So it is about the 5 meter. From which direction? So direction means you can measure from the top to bottom or bottom to top. So means such properties which are related with some material, they are independent of their direction. So such properties, such physical quantities are known to be as a scalar quantities. What they are? Scalar quantities. Okay, and some of them which are related by measuring. For example, I say that the car is moving in 20 meter per second of velocity in the direction of south. So means they are also here, they are calculating the direction also here. So means such properties which are considering with the direction. So means such physical quantities are called vectors. Okay, so means here physical quantities are the property of the material which can be calculated, which can be measured by quantifying them. Yes, and the second thing is, in the physical quantity we have two types. One is vector, another one is scalar, another one is vector. And the scalar is such quantity which is measured by independent of a direction, and vector is the one quantity which measured along with its direction. But in some sense we can say directly the scalar quantity is one which has only magnitude, and the vector quantity is one which has both magnitude as well as direction here. Okay, so you can understood what is meant by scalar and what is meant by vector and what is meant by the physical quantity. Okay, so well, we previously discussed about what is meant by vector and what is meant by scalar here. So I written here on the board the definition of the vector. So vector means any physical quantity which has both magnitude as well as direction. In other sense, we can say that the vector is what? The vector quantity is that which depends on its direction while it's measuring. Okay, so this is another definition for the vector. And while the scalar, what do you mean by scalar? The physical quantity which is independent of its direction while it's measuring. Okay, and or otherwise we can say that directly a physical quantity which has only magnitude. So means those physical quantities which are having only magnitude, they are called as scalars, or the physical quantities which are independent of its direction while measuring them. Yes, they are called as scalars. For example, we can take temperature. Yes, so 20 degrees Celsius, 40 degrees Celsius. So means here what we are measuring? Here measuring the temperature of one body, of atmosphere. Okay, so means in the sense means we are not able to take any direction at here. Yes, but in the time of scalars, in the time of vectors, for example, if I am started moving from one place to the another place, so means what happens? There is a motion. So means the vectors are maximally related to the motion, the bodies which are related to the motion only. And so now come at here another topic here. So how to represent a vector? So means the representation of a vector. Yes, so basically we can represent a vector by two things, means exactly by the two things. But while defining, we can define like this only. A vector is represented by a directed line segment whose initial and terminal points are specified here. Okay, so let us understand what it is exactly. Yes, so basically I told you the vector is going to be represented by two things. The one is the graphical representation and another one is the algebraic representation of that graph. Okay, so mean there are two things, graphical as well as the algebraic. Yes, so now let us understand this definition. So what is that? A directed line segment whose initial and terminal points are specified. Yes, the vector represented by a directed line segment. For example, if the line is traveling like this. Yes, so this is what the line L we have. If I say that this is a line L, yes, and whose has a direction in this way, where in this way. Okay. Yes. So now I will consider a part of this line. So means the segment of this line which is along the same direction. So segment means whose there are 2 points I will consider here. So point A as well as the point B. Yes. So this is what the vector where the directed line segment whose initial and terminal points are specified here. So mean this is what the point A is represented by. It is the initial point, and the point B is what? The terminal point, and it is in the direction of the line L. So means directed along the line L here. So means I can represent this. This is what exactly the graphical representation. If I say that L is the line and AB is what the line segment it is. Okay, if I provide a direction to this line, so means if it is provided in this line, so means so this will act as the vector. Yes, so it is called the vector AB. So means I can represent this vector AB in terms as a small letter alpha. The vector A here. Okay, so now you can understand what is meant by the representation. How we are going to represent here. A directed line segment is represented a vector whose initial as well as terminal points are specified. So means here, A is what? Its initial point, and B is what? Its terminal point. Yes. So now you understood how to represent it. So means this is the graphical representation, and this is what the algebraic representation of the vector. So where A and B are initial and terminal points. So look at here, while representation of vector, we have two things. One is initial as well as terminal. While measuring in the scalar, we can't distinguish the terminal as well as the initial point. If you measuring means just measure that quantity only from top to bottom or bottom to top here. Yes, for example, if I ask you what is your height, so you can say that from here to here, so means from the head to your feet. Yes, okay. So now you understood about representation of vector, and you can ask me one question at here. What is that question? So what we learned in the definition, any physical quantity which has both magnitude as well as direction. Sir, आपने हमें direction तो बता दिया, but what is its magnitude? Magnitude का मतलब क्या होता है? Yes, so let us understand what is the magnitude. So magnitude का मतलब इतना ही है, the length of that line segment. So means length of that vector का length होता है. So means from here to here. Yes, so means the magnitude is nothing but the length of the directed line segment. Okay, the length of the directed line segment. वो वही क्या होगा अभी magnitude, and we are going to represent it by in this notation. Yes, so this is what the representation of the magnitude of the vector. Magnitude of the vector here. I am not saying here line segment here. I am saying that the vector. So means you have magnitude as well as direction here. Yes, so this is what exactly the representation of the vector, and what is meant by his initial as what is a terminal point, and what is meant by magnitude here. Yes, so similarly we can take this point as like this also, magnitude of this way. Otherwise simply you can write this as an A only. Okay, so means if I say that directly this quantity as in this way, means it is representation directly a magnitude only. Yes, so so this is what about the representation of the vector. So okay, well, let us start with another thing. So position of a vector. So we know about vector, scalar, and how to represent a vector. So now let us know position vector. So what is meant by position vector? So before move to the position vector, we know some concept. What is that concept? Means the representation of a complex number in a plane. Yes. So for example, if I have z equal to be x plus I, so this is what our complex number. So how you are going to represent this complex number? This complex number is represented by in a plane by a point. Okay, we are representing a complex number by a point in a plane where our this is x plus iy. Here what x is the real part and y is the imaginary part. So means if you divide a plane, yes, so this is what we have x axis and this is what we have y axis. So means along x axis we are going to define the real part of the complex number, yes, somewhere in this way, yes, and along y-axis we are going to define the imaginary part of the complex number. So means exactly this z is somewhere at the point P of x comma y is. So means from here to here. Yes, so means here, so this distance is what about x and this distance is what about y here. Isn't it? So means this P at here we have O. So means the OP is what's the magnitude? So it is x square plus y square, and this is what the theta. It is called as an amplitude we have. Okay. So in this way we are going to represent a complex number in two-dimensional geometry. If suppose there is a point whose coordinates are P of x, y, z. So means here we have x and y only. So means there are only two variables. But in this case we have the three variable point here. So means we are representing this point in where some three-dimensional space. A three-dimensional space here. So suppose if the point is somewhere at here, I will provide you a diagram at here. Okay. Okay, so this is what the point P, x, y, z in three dimensions. So this is what x, this is y, and this is what we have z. Yes, and this is what origin. Yes, so here what we have the point, here also we have the point. So now here look at here, the position vector. So position vector is nothing but what we have. The position vector is nothing but the position of a point in a space with respect to the origin. Or in other case we can define this any vector which provide the position of a point in a space with respect to the origin. So means if there is a vector which represents from origin to the some any other point, so means this is what? Okay, so means this OP vector provided the position of the point P of x, y, z, where it is exactly situated, and this OP is called the position vector and it is defined by vector R here. Okay, and whose magnitude is what? OP vector. So means it is defined by this way. So means we know that what is meant by magnitude. So magnitude is nothing but the distance or the length of that vector quantity. So OP vector, so means it is the distance between the origin as well as the point. So it is x square plus y square plus z square. We have used here just the distance formula. So means nothing but here, let us recall again. So position vector is nothing but what? The position of a vector is nothing but is the position of a point in a space. Otherwise any vector which provide the position of the point in a space with respect to the origin. So आपको ये ध्यान में रहना चाहिए कि always we are going to define a position vector with respect to the origin only. So remember this point. Yeah. Okay. Well, let's move to the another topic here. The types of vectors. What are the types of the vectors here? Yes. So I listed here some types of vectors. Along with that, we have some another also vectors. But let us discuss these are the main points of the vector types. So now first went to the first vector, zero vector. So zero vector. What is meant by zero vector? The vector whose magnitude is zero. Okay. Magnitude is zero. Yes, the vector whose magnitude is zero, such vectors are called the what? The zero vectors or null vectors, and we are going to denote this vector as an O. The vector O is represented by zero vector. Now you can understand here when you say that any vector is zero vector. So means if I say that this is what the zero vector, what happened here? The initial point, the initial, what we say, the initial point and the terminal. What? The initial as well as the terminal points are coincide at each other. So then you can say that a zero vector has a zero magnitude. Okay, and the magnitude is zero means it is a zero vector where the initial and terminal points are coincide each other here. Yes. Now, so can zero vector has the direction? Obviously, definitely, because it is the point representing as a point. So means it can has n-dimensional direction. We can move it anywhere. Yes. So means the zero vector has a n-dimensional vector. Yes. So let us start with here. So next it is unit vector. So means here what we have, magnitude is 0, means here what happened, a vector is said to be unit vector whose magnitude is unity. So means whose magnitude is equals to be 1. Means if I say that from your college to your home, the distance between your college and your home is 1 kilometer. So it is not the matter of unit. So here what we have, the particularly 1. So means unity, 1 kilometer. So 1 is means the magnitude is unity here. Yes. So 1 kilometer, and we denote it by, it is a capital, and it is always defined by vector A divided by magnitude of vector A here. Okay, so means the unit vector is 1 whose magnitude is unity, and it is denoted by A cap and is defined as vector A divided by magnitude of A vector. अब आपको ये समझना होगा कि ये कैसे आ गया, how it is come. Yes, so let us understand. So look here, this is what our 3-dimensional. Okay, so now there is a vector A. Yes, this is O, and this is what we have, the point A, x, y, z. Yes, so now if I say that this is what the vector, its magnitude is what, magnitude of this much of magnitude has this vector. Suppose there is a vector acting along, this vector, उसका magnitude कितना है, 1 है. So means its magnitude कितना है, 1 है. Okay, so means we are representing, this is what the unit vector here. Yes, so now if this vector इस वेक्टर को इस वेक्टर से इक्वल होना है, इस वेक्टर को इस वेक्टर से इक्वल होना है, तो मींस अब क्या करना पड़ेगा, इस वेक्टर को हम a मैग्नीट्यूड टाइम रिपीट करना पड़ेगा, है ना. अब इसका मैग्नीट्यूड कितना है, इतना टाइम. सो मींस अब फॉर एग्जांपल इफ आई से दैट दिस इज व्हाट द 5 यूनिट. ओके, सो दिस इज हाउ मच ऑफ 1 यूनिट इसका मैग्नीट्यूड है. यस, सो मींस ये वेक्टर इस वेक्टर के बराबर होना चाहिए, तो तब इसको क्या करना पड़ेगा, 5 टाइम्स इसको रिपीट होना पड़ेगा, तभी इसका इक्वल होगा. सो मींस जो वेक्टर ए जो है किसके बराबर होगा, यूनिट वेक्टर इनटू द मैग्नीट्यूड ऑफ ए वेक्टर. सो मींस इट रिप्रेजेंटिंग द वेक्टर बाय इन दिस वे. यस, सो मींस मैग्नीट्यूड ऑफ द यूनिट वेक्टर कैन बी रिप्रेजेंटेड इन दिस वे. So this is what, how we get the expression for the unit vector. Okay, so remember this thing. Yes, so let us move on. Equal vectors. Equal vectors का मतलब क्या है. अब यहाँ पे जो मैग्नीट्यूड है 0 है, यहाँ पे जो मैग्नीट्यूड है यूनिट है. अब इक्वल वेक्टर्स का मतलब क्या होगा. So means if any two vectors are said to be equal, then and then only their direction as well as magnitude are same होना चाहिए. Yes, what magnitude and direction are same. Magnitude and direction are same होना चाहिए. For example, if I say that this is the vector A going in this direction, similarly the vector B is also going in the same direction, and whatever the magnitude has the vector A, it has magnitude of vector B also. Okay, so remember this thing. Okay, so next move to the co-initial vector. Co-initial vector का मतलब क्या होता है. So co-initial, so means co means का मतलब क्या है, same है. Initial means it's an initial point. So means if 2 or more vectors are said to be co-initial vectors, their initial point is common for all the vectors here. Yes, for example, if I say that this is the point O. Okay, there is a vector started from here to here, so this is what the vector A. Another vector is at here, another vector is at here. I'm not saying that are equal, they are just started from O only. their terminal points are different here, but their initial point are same here. So that's why the co-initial vectors are those vectors whose initial point is same. Okay, so such vectors are called the co-initial vectors here. So means the initial point is same. Initial point is same for all vectors. And next move to the another vector, it is the collinear vector. So collinear vector का मतलब क्या है? देखो नाम से यही पूछ रहा है co-linear. Co है और linear, same और linear same. So means the vector, any two vectors are said to be collinear vectors. They are parallel to the same vector or same line or along with the same line here. For example, if I say that this is what our 3 dimension is, so this is what our line is, and if I derive two vectors from here and here, so vector A, this is what the vector A and vector B here. Yes, the co-linear vector means the vectors are parallel to the same line or parallel to each other. Otherwise, they are along the same line. If I say that this is vector A and this is what the vector B here. Okay, so co-linear का मतलब होता है they are the parallel lines. So means it is the nothing but in generally we can say that the collinear vectors are a parallel vectors. So mean they are parallel. Okay, guys. And another thing of collinear vector is that, yes, I will write here parallel to same line or along the line. Okay, अब collinear vector का और एक चीज है. If I say that if vector A and vector B are said to be collinear, if vector A and vector B are said to be collinear, then there exists a scalar t, which is an integer or real number. There exists a scalar t such that the vector A is represented in the multiple of t into vector B here. So this is what the condition of co-linearity of two vectors. इसका मतलब इतना ही होता है, दो वेक्टर्स कोलिनियर है तो किसी एक वेक्टर को हम वेक्टर मल्टीपल स्केलर मल्टीपल ऑफ अनदर वेक्टर के रूप में हम लिख सकते हैं. So I mean this is what the collinearity of the condition. Okay, so remember this point. Yes, so I will erase it. Please note down this point also. Yes, so next move to the coplanar vector. So look here, collinear का मतलब क्या है? They are parallel to the same line or along the same line. Otherwise, we can represent one vector in terms of scalar multiple of another vector. So means इसी condition को use करके example को solve करेंगे. कौन सा? This is the one. Vector A is represented by scalar multiple of another vector. So this is what the collinearity condition भी है. Okay. So now here coplanar vectors. So coplanar vector का मतलब होता है if suppose two vectors are said to be coplanar. So co का मतलब क्या है? Same है. Planar का मतलब in a plane. So means if two vectors are said to be coplanar means they are lying in the same plane में रहना है उनको. ऐसा नहीं कि वो parallel है और non parallel है. Just they are lying in the same plane में होना ही चाहिए उनको. Yes, that we can say that they are coplanar. Otherwise they are called as a non coplanar vectors here. Yes, and they are lying in same plane. They are lying in same plane. Lying in same plane. Okay, same plane में हो रहना चाहिए. अब नेगेटिव वेक्टर्स. अब नेगेटिव वेक्टर्स यहाँ पे जो है हमने एक वेक्टर पढ़ा है वो इक्वल वेक्टर्स. सो इक्वल वेक्टर का मतलब होता है मैग्नीट्यूड एंड डायरेक्शन क्या होना चाहिए? Same होना चाहिए. And here what we have the negative vectors. So negative vectors are those vectors their magnitude same but they are traveling in opposite direction. Yes. So what here we have the magnitude. The magnitude is same but opposite in direction. Opposite in direction. Okay, so means if one vector is moving in this direction, means another vector is moving in this direction, but equally they are in magnitude. Yes, so magnitudes are equal here. So means we can represent a vector A is in this vector, so means minus of B vector. So means both are equal but opposite in direction. So that's why we can call it as a negative direction. Okay, so now another thing is what? So write this condition at here. The vector A is equal to B minus B vector. Yes. So now free vector. Okay. Well, let us move on free vectors. So what is meant by free vector? So let us consider a vector. So this is what vector A. So this is moving in the direction. Yes. So now here we have point A and point B. Suppose if I shifted this vector, at here somewhere like this, so vector C and D will denote its new vector. Yes, so means the vector is shifted from here to here, which is parallel to this vector, without changing its magnitude as well as the direction. Such vectors are called the free vectors. So means without changing magnitude and the direction, we are shift exactly parallel to the given vector, and such vectors are called the free vectors here. Yes. So now it is nothing but all the parallel vectors are supposedly to be being as in free vectors, and in this part we are going to be studying the free vectors only. Okay, maximum we are going to be studying the free vectors only. Yes. So we know that what are the types of the vectors, and let us understand these types of vectors with by an example. For example, yes. So there is an example given by in this way. There is a square. There is a square in this way. Okay. So this is what the square. Yes. So this is the vectors what way they are appearing in this way. Vector A, B, and C, and vector D. Yes, the four vectors are acting along the four sides of a square. Yes, they are asked to find out the initial vectors, initial vectors, co-initial vectors, and collinear vectors, and we have another zero vectors, and we have negative vectors, and collinear but not equal, and equal vectors. Okay, so this is what example is. Yes. So now, so look at here. There is a square. The four vectors are acting along the four sides of a square, and they are asked to find out co-initial vector, collinear vector, zero vector, negative vector, collinear but not equal, and equal vectors. Okay. So right, what is the solution? Yes. So now co-initial vector. आपको पता है definition. So definition का मतलब, so means co-initial means the vectors whose initial point is same here. So means for here look. So this is what the vector is starting from here to here and here to here. So means vector A and vector D, vector A and vector D, both are what? Co-initial vectors. Co-initial vectors here. And now here we have co-linear vector. So collinear का मतलब क्या है? The collinear vectors are those the parallel vectors along the line or the same line. Yes. So now vector B and vector D, they are what? The parallel vectors. So means vector B and vector D are parallel vectors, and also vector A and vector C are parallel. It is not the meaning of that the vectors are acting in the different direction. Collinear का मतलब है they are parallel. It is the neither it is the not the meaning consideration of its direction here. So means also here what? Vector A and vector C is also what? The collinear vectors here. Collinear vectors. Next, zero vectors. Zero vector का मतलब क्या है? So means if I say that suppose I say that this is a point A, B, this is C, and this is D here. Suppose I consider only this point A, this point B, this point C, this point D. Only point that will act as in zero vectors here. So means the point A, B, C, D, the points are what? Zero vectors. They are act as in zero vectors here. Okay. So now negative vectors. So negative vectors का मतलब क्या है? The vectors having same magnitude but opposite in direction. So look, this is a square. So that's why all sides are equal. So means magnitude of each vector is equal here. So now those are the vector correct. Those are vector. They have magnitude same but opposite in direction. So means vector B and vector C. So means here A and C. Vector A and vector C. What? These are the negative vectors here. Negative vectors. And next, collinear but not equal. ऐसा कोई वेक्टर इसमें नहीं है जो कोलिनियर है but not equal है. आपको yes? Are you familiar? So now here look, collinear का मतलब क्या है? They are parallel. So mean definitely this and this parallel, this and this are parallel, but they are not. ऐसा नहीं जो equal नहीं है. Equal का मतलब क्या? उसका magnitude equal नहीं है. So means this is what? Collinear but not equal. There is no such vectors. Yes, there is no such vectors. There is no such vectors. And next we have equal vectors. So equal means they are having same direction, same magnitude. And vector B and vector D, vector B and vector D are the equal vectors. Okay. So remember this thing. What is the coinitial, collinear? Zero vector, negative vector, collinear but not equal, and equal vectors. Okay. So this is what an example here. So if you want to another example, try to. I will provide an example. Try it in home. There is a regular example is there. Okay. So this is what the regular example. So this is the point A, B, C, D, E and F. So this is vector A. Okay. Vector B, vector C, vector D and vector E and vector F. So this is acting on this side. Here, here, here and here it is. Okay. So now use this diagram and find out this all vector. Okay. So try to find out. If you're not able to find out, please comment on comment it. I will be provide you the answer. Okay. So thank you.